So for this problem here, to prove whether or not it's an odd function, we would have to show that negative f of x equals f of negative x for all values of x. So what I'm going to do is, for the expression above, anywhere I see an x, I'm going to plug in negative x in parentheses and put this all on the right-hand side here. And then for the left-hand side, we're just simply going to put a negative 1 in front because it's just negative f of x. So when you see a problem like this, depending on what you're working with, you may want to work on both sides at once, kind of like a trig identity. But for this, you're actually going to be wasting a lot of time if you're doing that, or if you're trying to finagle the right-hand side by doing some cool factorization, things like that. But I'm here to help you out to save your precious time on your exam, because I want you to recognize one really important thing here. When you're dealing with the sine function here, you need to use this really cool trigonometric property. See, sine of negative x always equals negative sine of x. And this is useful because I want you to notice something. On the left-hand side here within the parentheses, you have a negative in front of an expression of x. So with that being said, can we now just manipulate this expression on the right? Okay, if you don't see it already, why don't we just factor a negative 1 out of all the terms so that we can rewrite that right-hand expression such that you have sine of, in parentheses, negative outside of the parentheses of x cubed plus x. Now, maybe now you don't see whether this is an odd function yet. And if you don't, that's okay. But if it helps you out here, check this out. We now have an x cubed plus x expression on both sides of this equation, right? So you could take this a step further now if it helps you out and just do a u substitution, or whatever letter you want to call it. I'm going to call it w. I'm going to say that let w equal x cubed plus x. That way, wherever I see x cubed plus x on both sides, I can put in a w instead. And here's the really cool thing. Look at this. When I plug it in now, isn't it pretty clear that this is that trig identity I told you about above? So this is a clear odd function, right? Now, say we took it a step further, which will lead into my bonus tip at the very end. What if you are now asked if this is an even function? If you know it's odd, the answer should be crystal clear and you should know it right away. And if you don't, that's okay. Because here, we can actually use some of the work above to save time on an exam question. See, for an even function, you would have to now show that f of negative x equals f of x versus negative f of x. So for f of negative x on the right, remember that when you plug in negative x everywhere, anytime you see x in that expression, we already showed on the right-hand side that because this is an odd function, it must be the case that it equals negative sine of x cubed plus x on the right. Now check this out. We've got this expression. You've got sine of x cubed plus x on both sides, but the only difference is that the right-hand side is multiplying it by negative 1. So other than 0, there's no way that these can be equal to each other, right? So with that being said, this is not an even function, but it's only an odd function. And now it's time for that bonus tip. Can a function actually be even and odd at the same time? What do you think? Okay, so remember, you have to now satisfy two conditions. To be odd, negative f of x has to be f of negative x everywhere. And to be even, f of x has to be f of negative x everywhere. But check this out. This is just a basic system of equations because you've got f of negative x on the right of the equal side in both cases. So why don't we do a substitution of one into the other? This would have to mean then that f of negative x, because it's the same as negative f of x, this means negative f of x must equal f of x. This is the only way that a function can be even and odd. Now, for f of x to be the same as negative f of x everywhere, there's only one possible function that could satisfy this. And I want you to tell me below in the comments as your homework.